Okay, will I be able to advance the slides, or are you going to do that for me?
I can do that for you. Yeah.
Okay. All right, so thank you all for joining me today. We're going to talk about careers in environmental science. My name is Catherine Quinn, and I'm a professional geologist and certified hydrogeologist. Next. So why would anyone want to do something in the environmental sciences? Well, because it's fun. If you love the outdoors and you want to protect Earth's natural resources, Earth or environmental sciences may be for you. Next. Here are some students in the field mapping a rock outcrop. These are sedimentary deposits, and these deposits are stored in the rock record, and they tell a story of ancient depositional environments. Next. So there are many applicable majors that can support you in your new career in environmental science consulting. Some of the majors that people choose in preparation for environmental work include the geological sciences, which in and of itself, in geology, there are a wide range of areas for specialized study. Some include geochemistry, geophysics, sedimentation and stratigraphy. There's, or paleontology. Some people choose to study more generalized topics such as earth sciences or environmental science. Even the biological sciences apply in the environmental field. And of course, the areas of civil environmental engineering, chemical engineering, and many other engineering fields are applicable to environmental problems. The coursework is very interesting too. When I studied earth sciences as an undergraduate, I took courses in geology, astronomy, meteorology, marine biology, and electron microscopy, in addition to all of my core studies in geology. And we took field trips to observe the Earth's characteristics and its changing landscape, identify fossils, and collect rocks and minerals. Next. I took a course in electron microscopy, which actually led to my very first job in geological sciences. These are super high-powered microscopes that allow us to see materials at the atomic level. Next. Here are some examples. This is an electron micrograph of a snowflake. Next. And these are electron micrographs of metamorphic quartzite rock in various stages of deformation and recrystallization. When I studied earth sciences, I had my own key to the observatory where I monitored variable stars over several days and weeks, and studied many aspects of astronomy. I climbed up on a big ladder like that to look through the telescope, and I rotated the ceiling of the observatory to the area of the sky I wanted to view, and then I opened up that big window. It was very exciting. Next. So in the environmental field, because the problems are so complex and affect so many different aspects of our Earth, you have a variety of career options. I've worked in clean water supply management and contaminated resource restoration. Folks who work to restore contaminated materials might focus their field of study on land contamination, groundwater, or surface water, or they might specialize in air quality monitoring, protection, and air quality planning through permits. There's also a wide field in environmental impact planning. Every major project requires an environmental impact statement under federal law or an environmental impact report in California law, where rare and endangered species of plants and animals are evaluated and protected by the plans in how the project is built. Growth-inducing impacts are balanced with the pros and cons of the project to identify what environmental impacts might exist and how they could be mitigated. And then there's another field of study in toxicology to evaluate human health risk. These are only a few of the options that might be available to you in the environmental sciences. Next. In clean water supply, you are probably aware that groundwater basins throughout the globe are a declining resource, and the water quality is degraded. Some of the folks, even at UCI, have studied satellite images from a satellite called GRACE that in 2015 evaluated groundwater resources globally. And they reported that groundwater is an important source of drinking water for more than 2 billion people worldwide. However, new research using NASA's Gravity Recovery and Climate Experiment, nicknamed GRACE, satellite data, discovered that 21 of the world's 37 largest aquifers are rapidly depleting past sustainability tipping points. So there is a huge field growing in water supply management, drought protection, and improvement of water quality. Next. You might study environmental restoration of polluted resources in air quality or surface water or even groundwater. And this wedge depicts a three-dimensional image that shows how industrial activities at the ground surface can cause impacts to the underlying soil that then seeps into freshwater aquifers that can be tapped into by water supply wells and impact the water quality that's distributed to cities. Also, these industries obviously contribute to air quality problems, and they affect soil quality as well. Next. In the field of risk assessment, which evaluates how these environmental releases might affect human health and the ecological resources, risk assessors consider it's called a conceptual site model. So we consider where releases may be occurring and how those releases enter the environment and may be migrating through the environment, ultimately being received by receptors, which are humans, whether they be residential or commercial workers, elderly or young children. There are exposure points that are evaluated and calculations are made to determine what the level of exposure might be to each of these individuals under likely scenarios. And from that, we back calculate an allowable level. So if contamination is discovered in groundwater, how much of this contamination must be cleaned up in order to protect human health and our natural resources. So this is a field that toxicologists often specialize in, and this is how chemists and biologists often enter into the environmental field. Next. As an environmental scientist, you have an opportunity to represent a variety of concerns. The environmental challenges are multidisciplinary, so you're constantly working in a team with people of a variety of backgrounds in education and experience. Your coursework in academia, as we discussed, will be varied, and you'll have an opportunity to enter academia, maybe as an earth sciences instructor for the primary grades, or have a specialized PhD degree and teach at the university level and perform research. You might enter a public agency like a municipality, a city or state government agency, where you would work on planning and permitting for new projects. Or you might work for government enforcement agencies such as the United States Environmental Protection Agency or the California Water Quality Control Board, for example, or the South Coast Air Quality Management District. You could enter private industry, and there you would be helping industry comply with environmental regulations and or learn how to safely explore for natural resources such as mineral resources or petroleum, and develop those sources in a safe and logically sustainable way. And finally, many environmental scientists choose a specialization in environmental law, or they write policy for the future generations. As we learn more about environmental impacts, it's necessary that we constantly update our policies. And environmental attorneys work to enforce those policies in a way that is sustainable for industry as well. Next. My story, I studied earth sciences as an undergraduate, and earned a bachelor's of science with a focus in geology, and joined mobile oil research and development, where I characterized zeolite minerals that were used for petroleum engineering applications. And I worked in a lab with PhDs from around the world. These were chemists, engineers, and various other scientists. It was thrilling, and I thoroughly enjoyed it, and it inspired me to pursue a higher degree, and I chose environmental engineering. I was able to secure a job as a consultant and work full-time while taking night classes. So not all of us have the opportunity to enjoy the support of maybe our parents' savings or sufficient grants, but it is possible if you really have the desire to even work your way through school. I did it, and it was the best investment I've ever made. I've worked with large environmental consulting companies in Orange County, and I've served public agencies, including U.S. Environmental Protection Agency, water districts and water supply, cities and other municipalities, and ports, the Port of LA and the Port of Long Beach. And I've served industry, sometimes through attorneys in very complex matters involving multiple responsible parties. Next. And ultimately in 2010, I founded my own consultancy. It's called Quinn Environmental Strategies. or QES Inc. It's a woman-owned business enterprise, and I have certification with the City of Los Angeles, as well as certification as a very small business enterprise with the Port of Long Beach and other agencies. We have a core team of 4 full-time employees, and we have an extended team. These are specialists in their field who consult with us on a part-time basis, depending on our client specific needs. We've been very successful with repeat business for our core clients, which include representatives from the legal field, attorneys, private industry, landowners, and land investors. And now we're expanding our marketing efforts to bring on board new clients who are in our existing market segments, as well as to expand into the public sector to work with public agencies such as the Port of Los Angeles and Long Beach. Next. So the qualifications for the environmental sciences field, you can see it's very diverse in terms of what you choose to study, but it's very important to have a bachelor's degree in science or engineering if possible. There are environmental studies programs as well. If you earn a master's degree or even a PhD in a related field, that also helps. I feel it's important to have strong people skills because, as I mentioned, these environmental problems are very complex, and specialists work together to solve multidisciplinary environmental problems. So you're constantly communicating and collaborating with other people who have a very different, although complementary skill set. I think it helps also to have good observational skills. We can have very specialized academic preparation, but it's also those practical common sense abilities that help us to interpret a complex data set in realistic scenarios, and to have good communication skills. The kinds of things that we study can be very complex, but our clients may not have a background in science or engineering at all. So we must learn how to translate data into meaningful findings for our clients and for regulators who are enforcing laws and legislation. We want to show them how our clients are complying. And once you've completed school and you have some practical experience in the field, you might choose licensing and certification. I'm a professional geologist, and there's also a professional engineer's license, and each of these has subspecialties. I'm also a certified hydrogeologist, which means that I work primarily with natural water resources like groundwater. Next. Some of the rewards of my profession are that the work is interesting always. I find it very exciting to have a variety of technical challenges so that I'm constantly sharpening my tool set, my knowledge and experience to try and resolve the next client's dilemma. I've done regional drought planning for water supply planning and management. I've worked with drinking water resource protection, and I've worked significantly in the area of cleanup of contaminated sites and protection of human and ecological health. So I'm constantly learning with this team of specialists. And the technology that's available to us is also evolving. So there's an opportunity for training and for patents. And I think there's a feel-good factor associated with this industry because we know that we're helping industry work cleaner and we're protecting our natural resources. And I kind of like working outdoors too. And I have the opportunity to do that from time to time, even still. Some of the challenges of my profession, well, first, it was kind of, I think everyone finds that getting your first job after college can be a challenge if you don't have practical work experience. So anything you can do to gain internship or any sort of work experience can be very beneficial to you in securing that first full-time job. The problems that we're tackling are very challenging, and so it does require some diligence, hard work, and sometimes long hours to meet deadlines. Sometimes we have to travel to remote project locations, which is exciting, but it does you know, have an impact on your lifestyle to some extent. And then there can be long hours of field work during certain project phases, and it's highly competitive. There are many people who are interested in this field, so you really want to prepare yourself the best you can with your education and your experience as you go in, and then learn and work hard. Next. Tips for entering the field. I would say tailor your school curriculum to your passions and your strength. This will give you a rewarding career. And as you can see, it's possible to contribute to the environmental field from a variety of backgrounds. So, you know, just listen to your heart and, you know, what you're good at and see where that leads you. You can specialize with technology, do some independent research, maybe with an advisor at school, get some work experience, and then be a good team player. Really be flexible and willing to support your team, even when the task you're handed that day seems kind of boring. It's all critical to the solution. So just roll up your sleeves and do the best you can with the task you're handed that day, and you'll be rewarded. And remember the big picture. Even if your role is highly specialized, ask how you can help and follow through with commitment. Be accountable. If you're assigned a task, see it through to completion, and you will be rewarded with interesting new projects and opportunities at every turn. Next. I reviewed the ROP and CTE course list, which was very exciting. I think you're very fortunate in IUSD to have these resources available. The areas of study that I felt would be applicable would be, of course, engineering and information technology. We often use numerical models to help us well, we use IT databases in order to store and manage large data sets that we generate. And then we use numerical models to help us interpret those data. So that, you know, computer skills are very helpful. And not everyone in the environmental sciences chooses to be in this kind of area. It's kind of a specialized area, but it's extremely beneficial to have that kind of background to some extent. And then entrepreneurship. You know, late in my career, I started my own business and figured things out on my own about all the accounting and human resources and documenting business processes. And so, you know, if you have a chance to pick up a business class along the way, I think it can be very helpful, whether you're an entrepreneur and have your own business, or you're in a managerial position in a larger business. You'll be able to contribute because you'll understand how the business operates. And in the ROP, there's a course in Principles of Engineering and then Information and Communication Technologies. So I think this is a slide that was added. Does anyone have any questions for me?
Okay, students, if you don't have any further questions, please take a moment to, let's take a moment together to thank Ms. Catherine Quinn for coming. You can give her a little hand waves. And as well, if you can thank you guys. You can also do the evaluation. It's listed right here in the slide here. You can use either the QR code or the tiny URL. And during this survey as well, when you came in, you did the entrance survey, will give you a chance to win a raffle gift card that is courtesy of PTSA. And so please take a moment to do that before we head on out. I'm going to stop sharing, but I'll leave that in the chat.
And I just want to thank all of you for taking the time to listen to my presentation. I really enjoyed sharing this with you today. Thank you.
Thank you.
Okay, I'm going to share that link in the chat, okay, students, and then you guys can do the exit survey.
Well, if nobody else has any questions, I'd like to ask something.
Oh,
So
good.
You mentioned how it's a competitive field. Are there any specific fields that are like particularly competitive, or overall is it just generally pretty competitive?
Well, there are a lot of different areas that you can go into, and I think the public sector positions, like with fish and wildlife, for example, might be very competitive. And then working as an in-house environmental compliance specialist in industry can be very competitive. For example, because they offer very high paying positions and they have great benefits, whereas the public sector offers competitive salaries, but even better benefits. And then consulting is an interesting area to go into, and you're constantly working to present your skills and capabilities and work well as a team so that you're selected for the next interesting project. So I think in that aspect, you might make it as competitive or non-competitive as you want it to be, depending on how ambitious you are and how selective you are on the projects you'd really like to work on. Same thing in academia. Academic positions can be very challenging to secure, but very interesting and rewarding as well. Did that answer your question?
Yes, thank you.
Okay.
I had a quick question. How can students now in high school kind of prepare themselves for this field, or what are some things they can do to kind of help demo their pathway?
Well, I think, choosing some coursework that's applicable, like the sciences and mathematics, to the extent that you can build your background with those in those areas, it's very helpful. Also, any kind of independent projects or science fair projects. I mean, we really do think that way. I mean, multiple working hypotheses. It's all about data analysis. And then, of course, your computer skills. That's important in everything these days. Any field you go into, it's all going to be applied digitally at some level.
Thank you. Students, if you have any more questions, you can just unmute yourself and ask away.
I actually do have a question.
Great.
So if you want to become an environmental attorney, what major would you suggest?
Okay, that is a great question. So, attorneys go to law school with a variety of backgrounds. But environmental law is specialized because the problems are really technical. So in my experience, environmental attorneys do very well to have some background in science or engineering. So if you were to do an undergraduate degree in any scientific field or engineering, or even do a minor, I think that would help you greatly to be an environmental lawyer. However, you might litigate environmental cases with no background in science or engineering as a litigator.
All right, students, did everyone have any more questions for Ms. Quinn? These are all really great questions. Don't be shy.
Yeah, I'm really enjoying this. Thank you so much for your interest.
I actually have another one. When you were younger, Ms. Quinn, did you always knew you wanted to be in this field?
No. Honestly, I always enjoyed the outdoors. I really did. But true story, I didn't know very much about geology. I enjoyed science. I was an undeclared major as a freshman. In my sophomore year, I met with a guidance counselor, and he told me about the earth sciences curriculum and all the field trips. And I thought that sounded like fun. And it turns out it was really interesting, and I loved it. And I also realized that the sciences weren't as hard as I was making them, because I found great motivation, for example, to try to excel in chemistry once I realized or had some courses in geochemistry or biology where it was applied. So once I saw the real world application in the natural sciences, the hard sciences, those core courses became a lot more interesting. Maybe that was too honest, but.
No, thank you so much for sharing that. And thank you again for being our speaker today. We really appreciate it, and we enjoyed your experiences and your presentation. Students, if you have no more questions, and if you already filled out that student evaluation survey, thank you again for coming, and we will see you at the next presentation. Everyone can just log off whenever they are ready, okay?
Thank you, guys.
Guys.
Thank you.